Alright guys, it's time for more of this Adventure R series on how to make an adventure game in C++. Where we left off last time, we had SCN files, our own file format that we created, parsing and working properly. Between that last video and now, I created the rest of the scenes for our snippet of our adventure game, and I've linked those together. There's nothing new in any of these. They use everything that we've already done. It's just the grunt work of me linking, the regions for everything that you can do. So let me show you that running. So basically you can start out at the bottom of the hill. You can go up to the middle point between the bottom and the first kind of hump. You can go to this area, which is kind of like the main, one of the only junctions I'm going to have. So that you can look down here. There's going to be an item here. You can look to the right. You can jump off the cliff and kill yourself, which I'm not going to do because I don't have a link back. And then you can go all the way forward to this locked door. And then behind that door there's going to be a kind of an entrance to the building. And if this was going to be a full-fledged game, that's kind of like where the adventure would start, right? But the basic gist is I can use the links to go anywhere I want, forward and back, throughout all the scenes in the adventure game, which is the basic gist of how an adventure game should work. What I'd like to do today is add something that every adventure game should have, and that's the text narrative. Now, I know certain games like Myst didn't have it, and not having text can kind of create a feeling of kind of like the player is by themselves and there's no narrative at all, right? So it's really up to you how you want to proceed. I prefer to have it, so I'm going to show you guys how it would work. And the way we're going to accomplish that is we're going to use the STL TTF library, which is the same font rendering library I used in my first series. I'm not thrilled about the way this library works. It does software rendering of the fonts, which is common across almost all font libraries, but the way you have to recreate the texture every time you want to change the string, I'm not all that thrilled about that, but it's efficient enough, and we're not going to run into any problems, and I'm just going to have to kind of bite my tongue knowing what happens under the hood as far as how inefficient this is. It's not going to cause a problem for this game, so I'm going to go ahead and just use it. So we're only going to have one font in our game, and that font is going to be loaded in the initialization of the actual game loop itself. So I'm going to go ahead and quickly just take care of that before we load the scene by just basically setting the font equal to TTF open font, and the name of that font is, I think I called it Crazy Pixel, and this needs to be part of our resources. I'm just going to put it in the image folder for now, and that indeed is called Crazy Pixel. I don't know the font size for this. I'll kind of feel it out at 12 and see how we go. It's important that every scene has access to that font. Now, if I remember correctly, when I render each scene, I do not pass back a pointer to the game loop. So I need to give access to the font to every scene. I could either do that via a static field of scene, or static data member, so that there exists one pointer to the font for every scene class, or I could just pass it into every scene independently. I think it would probably make the most sense for me to just go ahead and leave it as a normal non-static field, so I'm going to go ahead and do that. So I'm just basically going to have TTF font, and the gist of this is it's going to be set for every scene, and that's just how it is. Remember, I'm only loading the font once, so there's only really one instance of the font, but I can have as many pointers to it as I want. So that's kind of how this is going to work. Let me just hook that up real quick. No, it should be set font. There we go. Now you'll notice this happens to you a lot. Our name of the argument is the same as the name of the field or the data member of the class. Some people prefer to do this to distinguish. I prefer to just give it a slightly different name. either way is fine. It just up to personal preference. So now I have to make sure that every single time I create a scene, I give it a reference to the font as well. It might make more sense to make this a constructor argument. It doesn't matter too much as long as I make sure I always do this. So I just have to make sure the scene always has a reference to the font when I create one. So we're good. Everything's fine. And I cannot forget, which I like to do on destruction, destroy, free, close font on exit. Okay. So that'll get us running. Let me just make sure everything's fine and the font does indeed load without crashing. It does. Well, actually, cannot assert that until I check. Not font. We ain't found shit. See if you can figure out what movie that's from. Okay. And that's why you do that, because look what happens. Indeed, the font was not found. You can't forget to call TTFN init here, this will fail. Something I forgot to do. And I believe there's probably a TTF shutdown, quit, you have to do at the end. So that should cause the font to initialize properly, which it does. So now we can actually start drawing the text. So there's multiple ways I want to kind of approach this. First and foremost, we got to get the text into the scene class. So we're going to want to add that as what do I call that, directive of the scene file format. So I'm thinking of doing here is just having something that says narrative, quotes, and then what you're going to see or what is going to be narrated to you when you enter the scene. And this is essentially going to be words that are going to be typed out in front of you that you can see, and it's going to paint the mood of what you see. So I'm not really feeling creative right now, so I'm just going to say, you wake up on a hill, you don't know where you've been, what's going on. There's only one path, and that is forward. I'm probably going to change what this stuff says to make it more cool. But this is enough to get us started. So that's the idea. There's the narrative. I might add one for scene 2 just for good measure. Scene 2 will say, as you ascend, you see a strange light in the distance. Start to feel the temperature drop. Okay. I don't even know like if I use that word properly, but it's fine. So the idea here is this is going to be pretty easy to parse. The basic idea is when we are parsing our SCN file, we're going to check for the narrative directive, and then we're going to basically look for the quote. I can just do that. If the character that we read is indeed a quote, then we know that we have read in one quote, and we're going to continue to read in characters in a do-while loop until we hit the finishing quote to close everything out. Now another thing that could go wrong, there could be, for example, suppose I end the file and I forget to put the end quote. I could freeze up the game because it could loop forever as it hits the end of the file. So another thing that would be smart to do here is to make sure that the file is still good. In other words, it's still open. So that's what the do while loop looks like. At this point, what we're going to do is we're going to do INF. We're going to read the character one by one, and then we are going to insert the character into the narrative one by one. Now, those that are thinking ahead will probably notice at this point the final quote will make it into the narrative string, which is definitely not something we want. So one way to avoid that would just be to simply add another if statement here to make sure that indeed we add it if it's not a quote. And that'll take care of that problem for us. So at this point, we've parsed in a narrative, most likely. If for any reason I have an error that's already global. If for any reason that first character that we read is not a quote, then the person who typed out the file screwed up. So we're going to flag an error and we're going to break out. That'll basically run into the failed to parse runtime exception there. I didn't talk too much about throwing exceptions in the C++ series, and that's simply because I don't use try and catch very much at all. I might use it in very, very specific cases. In C++, it is a bad idea to rely too heavily on try-catch blocks because they can cause certain things like destructors not to run when they should and get you into trouble. So I typically will only use exceptions when I want to throw fatal exceptions that I intend to quit the entire game. I don't use them in cases where I plan on something 5 functions up to catch the exception. So that's just a little quick blurb about exceptions. So we have our narrative. In reality, the narrative should be a member or a field, and it is. So truth be told, we could probably just call this NRAR. I don't know what I want to call this. But I want it to be a local variable first. So I'm basically just going to call this text. Text will be set like so. And if and only if there's no error is when we're actually going to set our narrative field to text. So that's good. I'm going to verify that that went well by just adding a quick cout at the very end of all this that basically says narrative. And we're going to verify that we parsed it incorrectly. Now you'll notice immediately I did make a mistake. CN does not like to give you spaces. The whole point of CN is that it will skip spaces. I mean input streams, not CN. So that's something that we're going to need to take care of immediately because we can't have our narrative lacking spaces. It's just a momentary lapse of judgment. I forgot. Don't worry though, because we could just do C equals inf.get, and that returns every single character regardless of if it's a space or not. It's very similar. It's probably the smarter way to do this, so let's just go ahead and see what happens if we use inf.get instead of stream extraction, and we get our narrative, and it looks really nice. It's been parsed correctly. We didn't freeze the game up. Everything's just fine. So the narrative's good. Now we need to render the narrative on the screen, and this is actually where most of the complexity of this video is going to come in, simply because we want to break the narrative up into multiple lines if it is going to run off the edge of the screen. And I'd like to build all that into a separate class, and I'd like to call that class TextBox. And this is going to basically be a fancy text box, but we're going to start out kind of simple. We're going to walk before we can run. So class TextBox. I don't plan on doing any inheritance. The only thing it's really going to take in is some text, and you probably could guess it needs a font. These are almost going to be identical to the names of the fields, except no reference parameter for this. That's the same font pointer that we've been passing around all the way from the top, so nothing to worry about there. And the only thing text is really going to do is have an update method, which is ran once per frame, and a render method, which is ran during render time. And that's going to take an STL renderer as its argument. So let's go ahead and set these up. Come on. Come on. Okay. Now, these are allowed to have the same name of the fields because the compiler can distinguish which one's which. This is the C++ fancy way for initializing fields from arguments. It can only be done in a constructor. If you try to do that in another place, you'll get a damn error and your computer will catch on fire. And I'm not responsible for that. All right. What if I did one of these while drinking? That probably would be stupid. Well, anyway, update. We're not doing anything there yet, but in render we are. First things first, I'd like the text box to have kind of like a hard-coded size, which is going to be contoured to this game. If we want that size to be different later on, we can add that as a settable property. So here's our rect. That's the rect that everything is going to be drawn inside of, and that is also the rect that I would like to use to render kind of a dark block to kind of make the background of the text. So what I'm going to use is I'm going to do SDL fill rect, and we're going to, what the fuck? Render, draw rect, there we go. Nope, fill. I want to fill. I use draw rect to put a border around it. I probably will. No reason why not. I'm going to convert our own rect class to SDL rect, which is pretty easy to do, assuming the arguments are the same, which is probably they are. X, Y, width, height, they are. So basically I can just call R, set this equal to rect X, Y. If I wanted to get really fancy, I could do a mem copy, but that probably would be really stupid because, you know, yeah, never mind. That would be a big mistake. Okay, so we got render fill rect. We want it to be black. There's a renderer. We want black, but we want a tiny bit of alpha. In other words, maybe like half full alpha. And that should be enough to draw our text box. Again, like I said, I was going to hard code the rectangles. So that's basically going to be equal to a border of 5 on the left and top. And a width of 1280 minus 10, 720 minus 10 to give us the same width and height, the same padding on the other side. So if I do that and then just create a text box inside every scene, which I intend to do, include text box. I'm going to go ahead and implement this using a shared pointer. Course. Oh no, we're good. Text box. Text box. I don't set those to null pointer because the constructor automatically by default sets them as null pointers, the smart pointers. At this point, what I'm going to do is I'm only going to create one if there's a narrative set in the scene file. So basically, if and only if narrative isn't null, then I'm going to create the text box. I don't mean null, I mean empty. I'm going to create the text box using make shared. And I believe this takes an argument of the narrative and the font. And then when it comes time to render, if and only if there is a text box, we render the text box. And we forward along the renderer life cycle. Let's see what happens if I just run this. I think the text box is going to be up top and I want it on the bottom. Or, you know, there's going to be nothing on the screen at all. That can happen. Again, I always put not when I mean true and vice versa. So this text box is way too big. I don't think I meant for this to be 720. I meant for this to be like 100 or some value that's enough to take a part of the height of the screen, but not the whole thing. There it is. So there's our text box, and there it is up top. I'd like it to be in the bottom just because that's kind of how I wanted this to look, and I'd like it to be a little taller. So the way I'm going to do that is I'm basically going to say 720 minus 10 for the Y position, and then just 150 for the height. It should be fine. That's not correct. It should be 720 minus 150 minus 10. So there it is in the bottom. That minus 10 looks to be too much. It should be minus 5. There we go. So the only thing missing here is this should be semi-transparent because black could cover up some of the nice artwork of our game, and that's stupid. So what I'd like to do is set alpha blending, set blend, surface blend mode, set texture blend mode, set render draw. That's what I want. Renderer, SDL blend, blend. And I like to turn this off immediately if I could help it. Afterwards, let's see if that does anything. It does. 50% is not enough. Maybe I'll just set want until you get the value that fits what you're going for. One thing I'd like to do is also draw kind of like a white outline. So I'm going to go ahead and draw the rectangle again, but this time I'm going to draw it with the blend mode turned off and with a white outline. which is pretty easy to do. I think that'll probably do that for me. Okay, so you get the idea. It's not the most beautiful looking thing in the world, but again, this gets me started. As you know, I want to do more artwork or make this game into a real thing. I could play around with this. But this is where our text is going to be drawn. And as you can see, I've given myself enough room for a lot of it. Because I want it to be, like I said, I kind of wanted to paint a picture. And maybe down the road I might add things around here for like examine and stuff like that if I want to use other features. But I probably won't do that during this series. So let me go ahead and draw out the text. First and foremost, I'm just going to go ahead and just kind of try to render it and see what happens. It'll probably run off the screen. So the way you do this is this creates a surface for you. It's going to be a temporary, and we're going to do it every frame, and I know that's not great. But again, this is a tutorial, and it should be enough for most basic 2D style games. So we're going to use TTF, render text, UTF-8 text. We do not want it to be solid. We want it to be blended. And we want to use our font. We want to use our string. And we're going to want to use an SDL color. And I think if I were to just kind of check this out, this is probably... Okay, so they want RGBA in a struct. So color. I'm going to use probably white for the text for now. I was thinking red, but I don't want it to be too tacky looking. Let's see what this looks like, right? And then we're going to, well, hold on one sec. We're going to need a texture, and that texture is basically going to be created every frame. The reason why I'm doing this every frame is because I'm going to be changing this string via animation in just a sec, and it would make sense to kind of be ready for that. So SDL create texture from surface. We need our renderer. We need our surface. Once this is done, we do not need our surface that was used to create the texture, so we're going to wipe that out. And then we are going to render the texture to the screen using SDL render copy. Yes. Like this. Null for the source. For the destination, it needs to be the exact same size of the surface. So I believe what we want to do here, have a rectangle for text rect. This is not the same rectangle we use to draw the screen or the border, because if we do that, it'll stretch. What we want is the width and height position of where the text box is going to start, which is basically rect x plus 5. Actually, that's 10. 5 for the corner of the box, and then 5 more for padding. We might even use more. And then we want the surface width, surface height. Notice I am doing this before I destroy the surface so that it's still valid. And then we pass this in. Let's see what this looks like. It looks like a crash. Let's see why. Font was not passed in properly, which means by the time this is ran, set font has not been called yet, which is starting to really make me regret the decision not to make the font be a damn argument of the scene in the first place. I'm going to undo my bad decision and make this be the second argument of all constructors to the scene, so I don't have to screw around with this. And then font. You know, you try to plan, you know, as much as you can, but usually you got to kind of switch gears or make split decisions at the last minute here, you know, and that's just how it goes sometimes with this stuff. There's nothing wrong with that, and there's no shame in admitting it. If anybody ever actually was able to come up with a game and make no changes on the way and plan everything out perfectly, that person's a liar if they say they did that. Okay, we don't need this. I'm going to keep it around just in case I ever want to bring it back. Now, this should not be null. Look at how small that is. We need to fix that. I kind of knew that was going to happen based off of when I was reading the man code. This should be a lot bigger. Cool. So as you can see immediately, what's going on here, just want to make sure this is really alpha transparent. It's running off the end, which is what I expected and kind of what I wanted to happen, because I need to make this automatically split to the next line. It's also too far down, and that might have to do with just the way the font is. Some fonts like to have a lot of leading space on the y-axis. I could fix that pretty easily just by kind of adding a fudge factor here into the rectangle's y position. Basically just making it higher for me. Oh, I know what's going on. The font is rendering from the lower left corner. So what I basically need to do is subtract the font size. And maybe I'll just divide that by 2. Cool. Well, now we need to split the font up, and this is pretty damn tricky because down the road we're actually going to try to animate this and type one character out at a time.
So we need this to come up. We need to come up with a way to do this that's kind of...
So, brace yourselves, guys. It gets pretty complicated ahead. If you want to take a break before the last part of this video, now would be the best time. So we need this to come up. We need to come up with a way to do this that's kind of responsive, and we need to kind of. We're going to have to handle a lot of things here. Let me just kind of see what happens. That's cool. That's cool. I just wanted to see it happen. I wanted to see the narrative in both scenes. All right. Anyway, how the hell do we do that, right? Well, one solution would be to kind of have multiple lines of text so that we can render the text one line at a time. That's one solution. That's probably what we're going to have to do based off of how much the TTF render functions are exposed to us. So that's probably what I'm going to do, yeah. I'm basically going to have a vector of strings. I'm going to include that. A vector is an array. Remember, it's just a C++11 data structure. So we're going to have a vector of strings, and that's going to be our lines. We could limit the number of lines we want so they don't scroll off the bottom, because I'm not going to handle that kind of scrolling today. But the basic gist is we're going to be building these lines out by processing or the string as we come in. So right here in the constructor, actually I'm going to make a utility method here called build lines. And this is going to break our narrative out into multiple lines here. And we're going to call that right after we initialize from our constructor. So how do we do this? Well, there is a utility function for us that STL-TTF provides called TTF size UTF-8. And what this basically does for us is allows us to measure how much width and height a various string is going to take, and then go from there. And we need to do this in a way so that we can break up each line. And what I'd like to do is build this in a while loop and add a word at a time until we find that the next word would have spilled us past the boundary, and then start building the next line. So let me just kind of bear with me. Text processing is never fun, but once you get it, you get it. So bool, I'm going to have a base position here, which is going to be which character we're working on, and we want to make sure that this one is less than the text length. And then we're going to basically be moving this up, but we're going to be moving it up by entire words at a time, which is going to kind of be weird. So first things first, we're going to have the current line that we're working on, right? That's going to start out as an empty string. And we are going to then start adding words at a time into our lines. So basically, we have another loop in here, while text post is not a space. The way we determine something's a space or not is we include ctype, which is a C library. And we basically want to make sure that is space is false. and then we're going to build out. We're going to add to the line a character at a time. Yes, we're going to add to the line one character at a time, the whole part of the word until we encounter a space. Now, if we do encounter a space, we don't want to forget about that, so we still want to add it. And of course, we're going to need to increment our position within the string every single time we march through. So what this now determines is we've added one word. Once we get to a point where we've added a single word, then we measure the line so far. Now, the documentation of this thing says it will return 0 on success, which basically means nothing went wrong, which I'm just going to assume has happened. The output comes in as C reference parameters passed by address, and that tells us the width and the height of the font and the text, which is all it's asking for, right? I don't think I need this anymore. Yeah, that should be fine. Whoop, not text, damn it. Line, and then again we got to convert this to a C string so that the C code can read it. So at this point, we've determined the width of this, and we need to find out if this is too big. And the way we're going to do that is we're going to check the width, and we're going to see if that's greater than our rectangle's width. But it's not enough if it's greater than our rectangle's width. We also need to encounter some padding, and I think that's about 15 should be enough. We could play with this number. At this point, we've spilled over. Not only have we spilled over, we've basically determined that the line as it exists right now is too big to fit. So we're kind of fucked at this point. So we basically need to copy the line before we add each word to it so that we can back up to that position and call that really our true line. So we're basically going to have line, and then we're going to kind of have line next. And the way this works is line next is going to be set to a copy of line. And then line next is going to be the one that's built out. And at this point, we know line is safe to be added to our lines array. Again, I'm kind of rolling this as I go. I had no plan on how I was going to do this today, so this might not be the most efficient way to do this, but damn it, we're going to get it to work. So we spilled over, we got our line, everything's good here. I'm thinking of the next thing that can happen. So then we start building. Once we do this, line and line next both become empty, so that we can start building the next one, right? One thing that kind of blows at this point is that word that we created. This is why this stuff is ridiculous. That word that put us over the edge has now been lost. It's not a part of line, and it's really kind of not a part of line next either. So we actually need to back our position out back to the state it was before we started reading this line. And that's pretty easy to do. We're just basically going to call this pre-post, set that equal to post. If something went wrong and we spilled over, we just set post back to pre-post, which is totally fine. So then let's suppose we're parsing through a line that does not go over the edge. In that case, what would happen is we'd be adding to line. This would not happen once we've hit the end. And all we would do then is we would add the line as is to lines. And we'd be good at this point. I mean, we would totally be done. I mean, we would be finished. One really important thing here is that this loop does not keep going if we run past the end of the string. So we should add another and here and just make sure we really do not run past the end here. So that if that were to occur, this loop would end. We don't want this to happen if we've incremented past the end of position. So again, this isn't the cleanest stuff in the world, guys, but it'll get the job done. I'm just making sure I don't access past the end of the string anywhere. This never needs to be done here. And with any luck, this might just work. So let's just really quickly render the first line and see what happens. The assertion here is that we don't render anything if lines is empty. That's our array of lines. That would be stupid. So we don't even descend into this if the user passed, for example, a bunch of spaces or something ridiculous like that. I don't even know what would happen if that happened, but the general gist is we're going to render the first line just to make sure that my algorithm splitting code works for build lines. So where the hell is the, there it is. Lines, back, C string. This might not work, this is me just trying this out. It looks like we're in an infinite loop. So it looks like this thing got stuck. It happened because we got stuck on the space. So in this case, I do indeed have to increment position if and only if we fed in a space. Now we are ending up here with a crash. I once again flipped whether or not I wanted to do a not versus... Yeah, that should be line next. One issue I have here is that I'm never setting line ever. So at the very end of this loop, I need to be setting line equal to back to line next, I think. Meaning we're okay and we've committed everything out. Let me just try this. Okay, good, finally. So we built the first line. It looks like it's good, right? I mean, if we were to look at what I wrote on scene 1 and we were to see that there's only one path and then the end that is forward should be the part of the next line. So let me kind of take a look at the next line. So let's just render the lines in turn here. So the way I'd like to do this is basically this for loop becomes a moot point, or this if statement becomes a moot point at this point. Auto, line, and lines, which is a string. You don't have to use auto here, you can just say string. We want to render each line and we want to have a Y position. It starts at 0, which is kind of our base Y, and then every single time goes up by 48. And we want to add that to what we're rendering. At this point, I could then call... I think this should be an int. At this point, I could then call line.cstring instead of lines.back.cstring, and we should be able to render every single line. So it never adds that last line. The only reason I could think that might be happening is that I lose this for loop before this statement gets reached, in which case I should just add the last line here as well. Let's try that. That looks really good. I don't like the 48 that I've chosen for the incrementing of each line. Maybe I'm going to back that out to something like 32. That looks great. And if I go to the next one, feel the temperature drop and a foreboding sense of dread. So you can see that it's properly breaking and it's properly word breaking, which is exactly what I want this thing to do. So that's awesome. It wouldn't hurt for me to type more stuff to make sure that a third line works. Okay, so I made 2 more copies of it. I ended with some spaces, which could get me into trouble. That looks really good. It's obviously working perfectly. So I'm really stoked about that because I was definitely working on that multiple times. Okay, for a while. So yeah, cool. Last but not least, the last thing we're going to do here is I need to add more damn complexity to this. I want to type these out one character at a time so that it animates, kind of like the old school NES games used to. And that could even be made more fun. I could even play a sound effect with every keystroke, so I can have a lot of fun with that. That shouldn't be so bad now that we have our lines typed out. It actually really comes down to how much of each text string we want to render, and we're basically going to use a position. That's a terrible name. We're going to use a text. You know what? Position's fine. This is basically going to be the number of characters that we're currently at starting at 0. So that if we set this to 1, we get the first character. If we set this to 20, we get the first 20. And every single time we call update, we're basically going to add 1 character. Now to make it not rendered too quickly, I'm going to have a global here called t, or time. And what time's going to basically do is every single time we call update, we're going to increment that. And then maybe every other time we run this function, we are going to then increment our text position. And what that allows us to do is then use text position to render each line out with an animation. Now you'll notice I don't call TextBox update, so I need to make sure I do that. It even gets, no good, I have process for scene, so let's see. Here's process. That is, let me make sure I call this, yeah, this is fine. I basically want to say if I have the text box, you always have to make sure it's there because some scenes might not have it. I call text box update and we're good. And what this will allow me to do is build out how much of each the entire narrative I want to render. Now because this is split into multiple lines, this is going to get a little bit tricky, but it shouldn't be too bad. Basically what I'm going to want to do here is I'm going to want to have a string here, which is going to be a temporary, and that's going to be set equal to line, but it's not going to be set equal to line all the way. It's going to be set equal to a substring, and that substring is going to be text position worth of that string. It isn't enough to do this on its own because this can run off the end, so the idea here is that if the text position that we're currently working on is less than the length of the line, we can do this. Otherwise, the string is going to be equal to the entire line. Now this is a little dumb because it's going to end up typing both lines out together, but it should be enough for me to kind of get my bearings on exactly how I want this to work. I wanted to go 0, 2, I think, is what I want. Alright, so it appears that SDLTTF crashes and has a problem if you try to render a string that's completely empty, or it generates a surface that's broken. So this extra if statement makes sure that on the very first frame, when there's nothing in the string, it doesn't crash. So this looks good. It's going a little slower now, but this is basically what I want, except I want each line to render in turn. So the way I'm going to do that is... just look at this one more time. That's cool looking. I'm thinking that I would like to have this thing essentially spill over to each line so that if the text position will basically kind of keep like a rolling length of all the length up into and including all the lines. So the basic idea here is that every single time I render out a line, I'm going to do line's length, and I'm going to add to that the length of the line we just rendered, and then I'm going to subtract that from the text position so that it will always kind of go into the next line. At least that's my train of thought. So I can do this. Now the important thing here is that I don't let this go negative, which it definitely will for the for the other lines, because that would cause it to crash because I'd be trying to reference or index into a string using a negative number. So the basic idea here is that we do not render anything at all if text posts, which is the temporary, that's the offset of text position, is less than 0. So if we're greater than or equal to 0, we do this. Otherwise, we don't build out string at all. And that'll help, hopefully, with this problem. So, wake up on a hill. Let's just watch this type out. I'm hoping it goes to the next line and it just doesn't have a problem. That's freaking beautiful. And it didn't crash, so we're good. So I run this into the next thing. The speed of this isn't that big of a deal. I could dial this in. This is cool. This is worth it. It's kind of a pain to work with text directly, but you know, it's a really, really valuable skill to have. So I'm pretty happy with that. That looks really good. I could play around with it a little bit more. One thing that would make a lot of sense probably would maybe if I like clicked on the box, or if I clicked, it would move the text all the way out. Personally, I think a better solution would probably be to just kind of let this go a little bit faster. I do like it going slow because, like I said, it helps build the mood and it helps draw the player's eyes so that they're reading that instead of focusing. But once they've seen it before, they can just skip it, right? So that's kind of neat. So we're gonna leave with that today. That was quite a bit. Next time we'll probably start working on how to do items and how to deal with alternates. So thanks for watching, guys.